Interpolation. Suppose you have been given some set of data like this. X values are given from x0, x1, x2, xn, and also accordingly at this point the functional value f of x0, f of x1, f of x2, f of xn are given. For example, suppose you want to find the population of a census taken at 10 years in any country, that this x0, x1, x2, xn can represent the years, and these are the number of population on those years given to you. Now if you are asked to find out the population in between these 2 years, suppose this is a year, this is your year 1960, 1970, 1980 and so on, then if 1960 this is the population, 1970 this is the population. If we are asked to find out the population between at 1965, so you need to find out some sort of a relation between x and fx, some kind of a relation between this, a continuous relationship between this, so that we can find out those values. And this is what is meant by interpolation. So if I give it a definition, interpolation means finding approximate value of a function fx for any x between different x values x0 to xn, and at which the values of fx are given. These values may come from a mathematical function, or they may be measured or automatically recorded value of an empirical function, such as, for example, air resistance of a car, height of an airplane at different speed, size of population of a country as it appears from census taken at 10 years interval, and so on and so on. Whether the rainfall, amount of rainfall recorded, all those things can be recorded like this. And if we have to find out, or these points can also be written as in the ordered pair like this, x0, f of x0. Now if I draw these things in a Cartesian plane, so I can give these points in a nicely, we can draw this like this. If it is a these are x and these are your f of x, maybe this point is your x0, f of x0, this may be x1, f of x1, and so on. Okay, these points can be drawn. Now if I draw a straight line in these points, like these are f of these points, then we can have a linear type of relation between these two, this function, in this function. So our main aim is to be, the main idea is to find a polynomial Pn. So it will be polynomial. If I draw a straight line, that will be linear polynomial. Suppose we have 3 points here, and we can draw a minimum, a parabola including these 3 points, or these 3 points can be in a linear also. So maximum we can have a 2 degree polynomial or a linear polynomial if we have 3 points, and so on, if we can have different. So if it is a n plus 1 point, so we can have maximum n degree polynomial or less than n degree polynomial. Okay, so the main idea is to find polynomial Pnx of degree n or less that assumes the given data. So that data has to be fit. If you can find the polynomial, that polynomial has to fit the data. What does it mean? So Pn, this is the polynomial Pnx. If I put x0 here, that has to be equal to f of x0. Similarly, Pnx1 has to be f of x1, and so on. Okay. So the polynomial so formed, that is Pnx, is known as the interpolation polynomial. And these values x0, x1 and xn are called nodes. The polynomial Pn is an approximation of the function, or a polynomial approximation. So this function is approximated by this interpolation polynomial. Okay. Now when there is a need to find the values of f for any x between x0 and xn, it is noted interpolation, and the value of x needs to be extracted, and it is within these values, within this interval x0 to xn. If I need to find out any values f of x, any values of f of x in x belongs to these values, like if we have x belongs to x0 to xn, so if I can give this interval, then we call it as interpolation. And if you are asked to find out x outside, like x value may be less than equal to x0, or x value may be greater than equal to xn, like here or here. Suppose this is 1960, if we want to find value in 1955, or if this is suppose 2000, we want to find out value or forecast at a later date 2010, the value of function at 2010, then this is called extrapolation. So when there is a need to find values f of x and x between x naught and xn, it is known as interpolation, and the value of f needs to be extracted outside the interval, it is known as extrapolation. Now how we can find Pn? So Pn can be found depending upon how we are going to fit the data. If it is a linear, it will be linear function, it will be quadratic function, or it is a nth degree polynomial. Now for these things you need to find few things can be considered. One is whether x values are equally spaced or x values are arbitrarily spaced. As I discussed the census data, 10 years data, that will be equally intervalled, like 1960, 1970, 1980. So these are at the interval of 10 years we are taking the values of f of x. Okay, that is called equally spaced. But if we don't have that kind of data, for some arbitrary data we are taking, suppose we are taking 1 here, 2 here, then maybe 7 here, maybe 15 here. So that is not equal interval. We are not getting the functional value at equal interval. So those are called not equispaced or arbitrarily spaced intervals. Okay. So how we are going to find the polynomial is our next question. So in the next class we will discuss in this.